In this video, I'm going to show you how you can do sample size calculations for different forms of t-tests. So we've got three different types of t-tests we can consider. We've got independent samples t-tests when we've got two separate groups between subjects. We've got paired samples t-tests as well when we've got repeated measures designs. And we've also got a one sample t-test where you're comparing one group to a single value. For example, is your data significantly different from zero? So I'm going to show you how to do all three of those. To do this, we're going to use the Power package or the PWR package in R. So you'll need to install that package, and then each time you need it, you need to pull out your library. So it's a relatively straightforward procedure, and I've broken it down to different levels here. So our command is power.t.test. This is our t-test. And then we've got some information we need to give. And the first thing is n equals, and we leave that as null because that's what we want it to calculate. We don't know our n, but because we've got all the other information, it's going to be able to produce us our n. So we leave n equals blank. Then we need our significance level, our critical level of p. So in this case, it's 0.05. It often is, but it could be 0.01 or something else. The type of test it is. So this is your type of t-test. So for independent samples or between subject designs, we call it 2.sample. Then we say what our alternative hypothesis is. Is it two-sided or one-sided? Generally speaking, it'd be two-sided. Then you've got your level of power, so how much power you want. Usually this is done to 80% power, which is 0.8, although sometimes you will see 90% power, which we'd write as 0.9. And then we put in our expected effect size. So this is what the effect size we expect to see. So we give it that information. In this case, I've given it a 0.4. So we run that, and it will tell us what our n should be. And it also gives us a handy note, which we can now see, that says n is the number in each group. So that's really, really important, the number in each group. So we need 99 people in each group. That's when we've got our Cohen's d. Now, we could actually produce our Cohen's d in a slightly different way if you're interested in. We could calculate it itself. So Cohen's d is the mean difference between two groups divided by the pooled standard deviation. So divided by the overall standard deviation across the groups. So we could actually, if you don't have a Cohen's d, we could calculate what the Cohen's d should be. So let's say, for example, we've got two groups with in the previous study found a mean of 10 and a mean of 8.5, and the standard deviation was 1.9. So we can calculate our Cohen's d using this little formula. So we mean difference divided by the standard deviation, and we create an object called d for study. So I can run that. And then instead of putting d as a value, I can say d is our object, d for study. So we can run that. And we get our Cohen's d again. So it's calculated our Cohen's d for us. It's told us that d for study was a Cohen's d of exactly this value. And then we've got our power calculation there, and we've got our number of participants required. For a paired samples t-test, we follow a very straightforward procedure. So everything remains the same, really. Power.t-test, and there's null, because we don't know the number of participants. The significance level is 0.05. The type now is paired. So we say it's a paired samples t-test. Alternatives two-sided, our power is 0.8. And in this case, I'm going to do it for a Cohen's d of 0.4. So again, all we need to do is change the fact that it's paired and put in our Cohen's d that we're interested in. So we can run that. And again, we get 51 participants in this case. And again, n is the number of pairs. Okay, so it's very clear you need 51 people completing it twice. And finally, for our one sample t-test, it's a little bit different. Again, same command as before, same function, but now we've got n is null, significant level 0.05. Our type is one sample. So alternative is greater. That means we believe that our factor is going to be greater than our baseline comparison, what we are comparing our one sample to. So we can run that again. And we see we need 40 participants for that. So it's really straightforward to do these calculations. And really, the only thing you've got to really consider is the type. The type is the thing that changes. Then you're just putting in your correct effect sizes, your correct amounts of power, whether you want a two-sided test, and so on. But it's very, very straightforward to these calculations using the PWR package.